Hello and welcome to the part one of the quarter three test review. Part two will cover the second half of the review. So we're going to get right into it. This is going to go quick. So if you have any questions, rewind, rewatch. So I'm going to show a couple different ways you can do these type of problems for the square root. The first way is to look for perfect squares. So in this case, I would write this as the square root of 4 times the square root of 43, which is 2 times the square root of 43. The other way you can do these is what most kids have learned, which is using the factor tree. And then find pairs. So that'll be 2x squared times the square root of 3x. I'm sorry if that's kind of hard to see here. We'll slide that whole thing. The answer is there. All right, same thing for number 3. Do the factor tree. I'm sorry, that second one is a y. That's hard to read. So that's y, y. So circle pairs. So that'll be 5y times the square root of 2x. Now, this one's different because it's a cube root. So instead of looking for groups of 2, we have to find groups of 3. And so there are no groups of 3 in here, but there are 2 groups of 3x's and 1 group of 3y's. So that'll be x squared y. We need to be careful here. Sorry, that's also hard to read. Is the most common mistake is people do this and then that, but you must write in the index because you have to say that it is a cube root. All right, for number 5, another cube root. So this would be 3 and 9, 3 and 3, and x and y. And so we get a group of once again, cube root, so and once there are no groups of 3 in there, and then in the x's, there are 2 groups, so that'll be x squared times the cube root of 36x. All right, for each one of these, circle each expression that is in simplest radical form. So what they're asking us is there anything in the radical that can be simplified? No, so that's in simplest radical form. No pairs of x's. Here, 3 and 2, and x, nothing I can circle there, so that's in simplest form. This one is 2 and 9 and 3 and 3, and then in the x's, there's a whole bunch of matches, so that has not been simplified fully, so that one is wrong. All right, factor completely. So all 3 of these examples are quadratic trinomials, or have the highest power is 2, and the highest exponent is 2, and there are 3 terms. And if you are factoring a quadratic and a is 1, then what you're really looking for are what are 2 numbers that multiply together to give you 7 that add up to 8. And that will be x plus 7 times x plus 1, because 1 and 7 multiply together to give you 7, but 1 and 7 give you 8. This is the answer. If you were to FOIL that back out like we did in the second quarter, it would take you back to here. Lost volume. Accidentally pulled out my mic cord. So, apologize for that little delay. So here we will have, I need 2 numbers that multiply together to give me 9 that add up to negative 10. Those two numbers are negative 9 and negative 1. So this will be x minus 9 times x minus 1. For this one, it looks like a is not 1, but you will notice that all the coefficients are even, which means there is a greatest common factor of 2. So now I'm just looking for two numbers that multiply together to give me 3 that add up to 4. And so that would be for number 11, by the way, we're going to skip number 13. So for number 11, we have another problem where we can pull out the greatest common factor. This is going to be 5 times x squared plus 3x plus 2. So I need two numbers that multiply together. So this will be 5 times x plus 2 times x plus 1. All right, number 12 is a tricky one because the way you do this is by factoring the top. Factoring the top can be a little nasty. So first I'm going to factor the top. I'm going to rewrite them in the correct order. Now, on this problem, a is not 1 and there's no greatest common factor. So a is 3 and c is negative 5. So a times c is negative 15. So what I'm looking for is two numbers that multiply together give you negative 15 that add up to negative 2. Those two numbers are negative 5 and 3. So I split this. So this will be 3x squared minus 5x. So let's see the split here. Minus 5x plus 3x minus 5. And we're going to group the first two terms and the last two terms. And this the only thing I can pull out of the first two terms is an x. And there is nothing I can pull out of the second two terms, so I just write a 1 out front. But if we did this correctly, this and this are the same. And so this will be x plus 1, which are these terms here, and 3x minus 5. So coming back to this original problem, I can write it as 3x minus 5 over x plus 1 times x plus 1 over x plus 1. Here, the x plus 1's cancel, and so my final answer is 3x minus 5. Once again, that was probably one of the hardest problems on the review. So for number 14, which one of the following functions has exactly two different zeros? Well, a and b are linear functions. A straight line only crosses the x-axis once. So both of those are out. Now, c and b are both quadratic, so they're going to be parabolas. And the easiest way to do this is to actually just look at the graph. So I will graph both. The first one is x, let's put it out, x squared plus 4x minus 12. So I have no trouble typing here. And the next one is x squared minus 6x plus 9. So there are the graphs. There's the first one. That has two zeros. But here's the second one. If you look, you can see right here, it only has 1 0. So the correct answer is D. All right, identify the x-intercepts of the equation below. There's two different ways to do this. Once again, the easier one for you guys is probably going to be to graph it. So this will be x squared minus 11x plus 24. And if we look at the graph, the zeros are 3 and 8. So we can just say 3 and 8 on my solution, on my zeros. Now the other way you could do this is you could factor this as x minus 3 times x minus 8, and then solve each factor. X minus 3 equals 0, or x minus 8 equals 0. So x equals 3, or x equals 8. both are correct. For number 16, sorry, that should have been an X as a typo on the review. So, just verifying, just pausing here for a second, making sure we're still recording, is that, once again, the easiest way, I'm going to show you one more way. Ooh, I can't do that on this calculator. Another way to do this, and unfortunately, my onboard emulator doesn't have the app installed. If you go to apps on the calculator you have in class, you'll see something here that's called polysmult 2. If you use that, you can use that to solve these kind of equations. Unfortunately, that's not here, so we're going to have to take this old school, or maybe we're not, actually. So, or we can just graph the equation. So we go, y equals 3x squared minus 16x minus 12. And yeah, unfortunately, the graph here is, if you notice, is between 0 and -1 and 0. So we're going to have to do this by factor. So a times c is -36. So what I need are two numbers that multiply together to give me -36 that add up to -12. So those two numbers will be -18 and 2. So this will be 3x squared minus 18x plus 2x minus 12. Because we split -16x into two pieces. And we group, and we pull out the greatest common factor. So this will be 3x times x minus 6 plus 2 times x minus 6. So this will be 3x plus 2 times x minus 6 equals 0. And the zero product property says that if two numbers multiply together to give you 0, then one of them must be 0. And so if we subtract 2 from both sides, and divide both sides by 3, then you get x equals -2/3. And that is that right there. The other one is 6, which comes from there. All right, next problem. What is the solution set of the function? So once again, we can do this the same way. We can factor, we can look at the graph, we can use the polysmult app. Any one of those is a legit answer for this problem. If we look at the graph, which for now with the calculator I have is probably going to be the easiest way. Graph it, sorry. Y equals x squared plus x minus 6. And look at the graph, and the x-intercepts are the zeros, and when the equation is set equal to 0, those are the solutions. So my answers are -3 and 2. Now the other way we can do that problem is by factor. So factor as x plus 3 times x minus 2 equals 0. And one of the key understandings we need to have that is that if the factor is x minus 2, then the solution is positive 2. If the factor is x plus 3, then the solution is -3. And the reason that is because of what we previously talked about, zero product properties, that if I solve this, I get that. Now, for number 18, we're going to skip that, and you're going to ask your teacher about how she wants you to handle that in class. So you're going to have to ask your teacher about that one, because different teachers are going to handle that one differently. For 19, the graph of y equals x squared plus 6x plus 5 is shown. On the grid, identify each of the solutions to the functions. So the solutions are the zeros. And if this was on the SOL, you would literally just make points there. 20 is the same thing. Identify the zeros. For 21, it asks you to identify the x and the y intercepts. For 22, identify the x and the y intercepts. All right, so now we're into the rules of exponents. So we have to know the rules. So here, in number 23, we're raising a power to a power. So everything inside the set of parentheses has to be raised to the second power. So that's going to be 25. And then when you raise a exponent, a power to a power, you multiply the exponents. So we will have that. Now, this will be 125x to the negative 11th power. But you shouldn't leave a negative power in your final answer. Now, this negative 11 only refers to the x, not to the 125. So that'll be 125 over x to the 11th power. Sorry. For this one, for number 24, if you divide two numbers with the same base, you subtract the exponents. So our final answer is x to the 7th over y to the 4th. Which should make sense if you think about them canceling. The leftover x's would be on the top, and the leftover y's would be on the bottom. 25 looks like a hard problem, but remember, anything raised to the 0 power is simply 1. All right, find the area and the perimeter of the rectangle below. So the area is going to be x plus 1 times 2x plus 5. And we should probably FOIL that out. So that'll be 2x squared plus 5x plus 2x plus 5, or 2x squared plus 7x plus 5. This area is just length times width. Perimeter, though, is you add up all the sides. So that'll be 2x plus 5 plus x plus 1 plus 2x plus 5 plus x plus 1. No, that's plus. So 2x plus x plus 2x plus x is 6x. And 5 plus 1 plus 5 plus 1 is 12. 27, simplify. So here, this is a tricky one. Remember, if you subtract something in parentheses, you have to distribute the negative. So I always like to rewrite these. And then we have to combine like terms. Well, remember, in order to combine like terms, they not only are the same variable, the variable has to be raised to the same exponent. All right, for this, don't make this harder than it has to be. This is an x squared, so that's 1, 2. So that's 2x squared. 1, 2, 3, 4. Sorry, 2x squared plus 4x plus 2. For this one, 1 x squared. 1, 2, 3, 4, 5, 6 plus 6x plus 9. That's all we have to do for those. All right, for systems of equations. This is another one where if it's written in general form, you can use the Poly Small app. But we're going to go ahead and do these correctly. So there's elimination or substitution or graphing and finding the point of intersection are all ways that we can solve systems. So for this one, I'm going to use elimination. I'm going to we look for where either coefficients are the same or additive opposites. In number 30, the coefficients of x are the same, so I will subtract the two equations. X minus x is 0. 2y minus negative y is 3y. And 14 minus negative 1 is 15. And I just divide both sides by 3, and I get y equals 5. So x minus 5 equals negative 1. So I can sub in this equation. Add 5 to both sides, and I get x equals 4. So my solution is 4, 5. For the 31, I'm going to use substitution. The first equation is solve for y, so I will write the second equation. But instead of writing y, I will substitute in the whole first equation. Now, it's very important that you write it in parentheses, so we know we have to distribute the negatives. So this will be 2x minus 3/4 x plus 2 equals 8. So this now, this boggles your mind on what I'm doing here. Don't worry, get into DeLorean, go back to 5th grade and learn how to do your fractions. On the other hand, just do 2 minus 3/4 in your calculator and being enter as well as another option. From here, we're just finishing the algebra equation. Then we need to plug back in and find the y again. Wait, I just realized I made a mistake. Okay, I wrote the second equation down wrong. This should be negative 8. So everything's fine up until here. So let's just erase, go back, I apologize. So this is negative 8 and this is negative 8, so this is 5/4 x. I subtract 2 from both sides equals negative 10. So I multiply both sides by 4/5. And I get x equals negative 8. There we go. So then I can just plug this negative 8 into one of these two equations. So 2 times negative 8 minus y equals negative 8. Or negative 16 minus y equals negative 8. Add 16 to both sides, and I get y equals, negative y equals 8, so y equals negative 8. So my solution set is negative 8, negative 8. Sorry about that. I'll work on the problem correctly. During a sale, Ted sold a total of 56 more hats and shirts. He sold 34 more hats. If he sold 34 more hats than shirts, gotta be careful there, I'm going to say a bad word. How many shirts did he sell? So what we need to do is we need to set up two equations for this. So we're going to use h plus s equals 56. Then he sold 34 more hats. So in order for these to be equal, for hats, these two sides to be equal, we have to add 34 to the shirts, because if we had 34 plus shirts, then they would be equal to the hats, because the hats he sold more hats. Now we can just use substitution. So this will be s, because this h we'll sub in for there. So s plus 34 plus s equals 56. So that'll be 2s plus 34 equals 56. Subtract 34 from both sides, and I'll get 2s equals 11. Divide both sides by 2, and I'll get, 2s equals 22. Got ahead of myself there. Then I'll divide both sides by 2, and s will equal 11. And it asks for how many shirts he sold, so that's our answer. He sold 11 shirts. Now you can double check your work. If you did 11 plus 34. That means he sold 45 packs. And 45 plus 11 is the 56 total. All right, number 33. During a sale, PO sold a total of 74 cars and trucks. So C plus T, sorry, it's not neat. C plus T equals 74. I'm going to fix my T here so you're all clear on what we're doing. Right, it's a cursive so it doesn't look like a plus. If he sold 26 more cars, so we know these are going to be equal somehow, but how do we make them equal so that everything balances? Well, if he sold 26 more cars, then we have to add the 26 to the truck so it balances. And then once again, this is the same problem as before in the use substitution, and I can go T plus 26 plus T equals 74, or 2T plus 26 equals 74. Subtract 26 from both sides, and I get 2T equals 48. Divide both sides by 2, and I get T equals 24. Sorry. T equals 24. And once again, we can check our work. 24 plus 26 is 50, plus 24 is 74. So he sold 24 trucks. All right, we're down to our last couple problems here. So how do we graph a system of inequalities? Well, we graph each one of the inequalities, and then we shade these point of intersection. This is also a great time if you're running apps to run the inequals app on your calculator, which unfortunately is not installed on my board calculator. So, so to graph this, how would we graph y equals x minus 3? Well, we have a y-intercept of of negative 3 and a slope of 1. And it's less than or equal to, so we will have a solid line. And from that solid line, we would be shading down because y is smaller. So we will shade down from the line. So we would shade all of this. Actually, let me see if I can get a little bit fancy with that on smartboard. So we would shade all of this. For the second equation, the y-intercept is 2, and the slope is 3. But now we're going to shade up. Oh, let's read that up, sorry. So that would be shading that. So what we need to do is extend these two lines just a little bit, because we're going to shade up from the second line, which actually I need to redraw. Why? Because it is. But we're going to shade up from the dotted line, but down from the solid line. So I'm actually going to erase all of this, because the intersection is going to be here. All right, 35, graph the system of inequalities. So 1/2 x minus 4 is going to be a graph that looks like that. And again, this will be a dotted line. up from this line. And then the next line will start at 1 with a slope of 2. And we'll be shading down from that line. So I'll do another dotted line here. I'll use a different color this time just for clarity. And we'll be shading down from that line. So down from this line and up from this line. So our shaded area is in here. Once again, if you have any falls out on your calculator, that's very, very helpful. If you have any questions on these problems, I know I went pretty quick, please bring them to your teacher before your test. Good luck.